All right, so the other day, boys and girls, we talked a lot about the factors. And a factor are two numbers that you can pull out to get 12. So you might be saying, all right, well, what are my factors of 12? All they're asking you to do for this one is to write your factors of 12. So I know 1 times 12 is 12. Okay, I can do my rainbow method. What are two other numbers I can multiply together to get 12? I know I can multiply 2 times 6, and that will give me 12. And there's one more, 3 times 4. And so then the next thing they want me to do is to find my factors of 36 and then find the GCF of 12 and 36. Well, my factors of 12 are already up here, so I know I just need to find my factors of 36. Well, I have 1 and 36. 36 is even, so that means I should be able to do 2. 2 times 18, I know is 36. Okay, 3 and 12 will work. Don't mind my really bad hoops. 4 and 9 should work. And then the last one will be 6 times 6. So these are my factors of 36, and here are my factors of 12. So when I go through, they want me to find the GCF, which means I just need to take my highlighter and circle the numbers they have in common. So they have 1s in common, they have 2s in common. What else do they have in common? 3. Okay, they have 4s in common, 6 in common, and the biggest number they have in common is 12. So my greatest common factor for these two boys and girls will be 12. So you might be saying, all right, Ms. Podorsky, well, how can I figure out another way to do this? I know we watched the ladder method. How can I do that? So for the ladder method, what I'm going to have you do is somewhere on your notes, okay, you are going to take your pen and you're going to do 12, and you'll also do 36. Now, what number can come out of 12 and 36? There are a few numbers. They're both even, so I'm going to pull out 2. Well, 2 times what number is 12? Should be 6. 2 times what number is 36? Should be 18. Can anything come out of 6 and 18? Well, I know they're both even, so I'm going to pull out a 2 again. 2 times what number is 6? Well, 2, 4, 6, so I know it's 3. And 2 times 9 is 18. Can anything come out of 3 and 9? Yes, the only factors of 3 are 1 and 3, and I know I can take 3 out of 9 because 3 is a factor of 9. 3 times 1 is 3, and 3 times 3 is 9. Nothing can come out of 1 and 3 besides 1, so I just need to multiply my numbers here on the side. So they want to know, what is 2 times 2 times 3? Well, 2 times 2 is 4, 4 times 3 is 12, so my GCF must be 12. All right, let's go on to our next slide. So when I look at our next slide, they want to know what is a prime number. Now, a prime number are those numbers that have nothing else that can come out of them. So a prime number, I'm going to put prime right here, is a whole number greater than 1 with only 2 factors. What do I mean by that? Well, look down here. Anything that's red, so 11, 13, 17, they only have 2 factors. The only factors of 17, boys and girls, will be 1 and 17. There are no other numbers that can be multiplied together. So anything that's red here are prime numbers. Nothing can multiply together besides 1 in itself to get 17. Sorry. Okay, so a prime number is a whole number greater than 1 with only 2 factors. It only has 2 factors, example, 1 and 17. So that is prime. On the other hand, a composite number is a whole number greater than 1, not 21, 1, with more than 2 factors. They have more than 2 factors, so everything that's gray on this previous slide has more than 2 factors. An example would be 6. You can multiply 1 times 6 or 2 times 3. They're not prime, they're composite. So numbers are either prime, meaning they have 2 factors, 1 in itself, or composite, meaning it's a whole number greater than 1 with more than 2 factors. Okay, so what does that mean? Okay, we talked about the ladder method, and we talked about how to use the rainbow method to find this. The prime factorization method is also a effective method that a lot of students use to find the GCF. So the prime factorization aims to find the prime numbers that will break a number down into a tree. So if you look, if 30 is my number, they just want you to break it into a tree. So this person said, okay, well 30 has two factors. I can multiply 10 times 3 to get 30. Okay, 3 cannot be broken down anymore because 3 is a prime number. It's over here in red. So if 3 is in red, it's a prime number, I need to circle that. Okay, nothing else can come out of 3, which means 10. Well, what can 10 break down into? It can break down into 2 and 5. 2 times 5 is 10. Okay, so when I do that, the factor tree will break a number down, okay, based by its factors to get smaller. Okay, so the prime factorization for 30, notice how they write them down here from least to greatest. 2 times 3 times 5. Well, you can track your work. 2 times 3 is 6. 6 times 5 is 30. When you have the correct prime factorization listed, the numbers should multiply together to give you where you started. Let's go ahead and try this one. What is the prime factorization of 90? Well, on your sheet of paper, I'd like you to write 90. Okay, and 90 can be broken down. Now you might be saying, Miss Haas, how do I choose which factors to use? Do whatever's easiest for you. So I know that I can do 9 times 10. Okay, well, can any two numbers be multiplied together to get 9? Well, yeah, 1 times 9, but can I break it down further? What two numbers will multiply together to give me 9? Well, I know 3 times 3 is 9. And 3 and 3, boys and girls, are my prime numbers. And so now we need to get over to 10. What can come out of 10? Well, two numbers that multiply together to give me 10 will be 2 times 5. So I will go through and I'll circle those, and all of my tree branches now have prime numbers at the bottom, so I now need to show what I multiplied together. So I have 2 times 3 times 3 times 5. How do I freeze this?